Hey everyone, this is a follow-up to a previous tutorial where I showed you how to build your own databases to use with the NIST, NIJ, DIT. In this video, I'll show you how to move, how to include your databases in the DIT, and then use them as you need. So these are our three databases. I'm going to leave them here for now. I'm going to create another tab, and I'm going to show you where my DIT is. So I always put my DIT in my C drive. I've got my own version, but you can obviously download the version that's the true release version that I showed you in the previous video. That's on the internet. And now, again, there's a lot going on here, but if you want to update your database, or add additional databases, you just go shiny DIT, libraries, and these are all the libraries that I have right now. So I've got a library that I have with the Environment and Climate Change Canada, a rodenticide library. Great. A couple of evaluations I did for NIST, as well as an old version of HE positive inchworm. So what I'm going to do is I'm just going to copy over my three new databases, Control C, add them to my library folder. So now all of these libraries should be accessible via the DIT, and I can search any one of them. So I'm going to go back to my DIT folder, and remember, I'm on a Windows computer, so I can just run DIT. If you happen to be on a Mac and still want to use the DIT, you can just and you have R installed because you've built your own database, you just open this run app DIT and then run the app through R. So I'm going to run DIT. Note that this program was downloaded from the internet. You should, and it doesn't have a valid digital signature, but it's published by me, so I'm going to run it. The first time you run this, it might take a while because what we're doing is we're kind of looking for your default browser and making sure that we can run this R portable version. That's why it's all zipped together in one thing. But here it goes. It opens in your default browser. In my case, it happens to be Microsoft Edge. And before I do an example search, I'm just going to go to my libraries folder and the libraries tab. And it's taking just a second. It's loading. This is an old version of inchworm, so it's the biggest library that I have right now. But you can see that you have the library, you have the names, you got formulas, synonyms, base peaks. I'm going to scroll down a little bit more. N plus H, so the protonated molecule, all of that jazz is here. I'm going to update so you can see now, all the different libraries that I've installed. So let's look at the basic YouTube one. So what I want to point out here is we have no metadata. So we don't know the formula, we don't have the synonym, we don't have base peaks because we didn't include any of this information in our folder, but we do have spectra, and they all happen to be searchable spectra, so that's great. But they haven't been evaluated, so they're all blue colored. There's no and you'll notice there's no structure here. So if I go back and now open my full YouTube RDS, you'll notice there are some gray peaks. So these are peaks that weren't necessarily explained using the quality algorithm, but because we had the smiles installed, we had the smiles included, we have a structure for it. If I scroll down, we had other information about each of the compounds. And so that's all included. So that's the biggest difference between the full and the basic, is really just the amount of information. And I can also showcase Sam Houston's library. Great. So again, we built a basic library, so there's not much to showcase there. But the spectra are available. Actually, while we're at it, I'll just showcase the Environment and Climate Change Canada library. In this case, we didn't do any evaluation, but these are all rodenticides, so you can see we have what we have. And so you can build your own libraries and you can search them. So I'm going to go back to the basic YouTube library. All right, and let's go to the search tool. So now, let's say I wanted to do some library searching, and I'm going to search against the basic YouTube library. In the DIT, and so that's my class, DIT, there we go. There are some example query spectra. I'm going to pick, let's just pick, here we go, mixture 3. I like this mixture. I'm going to take the low fragmentation spectrum. That's our lowest, our first thing that we search, or sorry, the first thing that we need to identify targets, and I'm going to search it. And what you'll notice is there are 5 potential targets in that mixture, and the targets are identified by being higher than some relative intensity threshold. And for 2 of the 5 targets, we have potential matches in the library. For target 323.2135, we've got acetylfentanyl and benzylfentanyl. For target 2 at 150.1295, we have methamphetamine. Target 3 doesn't have any potential identifiers, although those of you that are familiar with mass spec will be able to tell quite quickly that this is the isotope, or sorry, the isotopic peak for the 323 that was target 1. A 91.05, which we have nothing for, and a 119.087 that we have nothing for, right? And also I want you to notice, so the scores, let's just, for this sake, 986 for FPI for acetylfentanyl, 945 for benzylfentanyl, but there's no isotope ratio calculation because there's none of that information in this basic library. If I update my library to the full YouTube library and search my library, you'll notice it's the same query. I haven't changed anything, but now we've got a couple more things that are identified. So our scores haven't changed because it's still the same. Fundamentally, it's still the same mass spectra, but now we have an IRD score. So that's the isotope ratio difference because we have those pieces of information. And now our target 3, which was previously unidentified, now has a potential identification as an isotope match. Our target 4, which was previously identified, now has a couple potential identifications as either the base peak of amphetamine or a major fragment ion of methamphetamine. And our target 5 still doesn't have a potential match, just our library only had 4 compounds in it, so it wasn't a very comprehensive library. But yeah, so that's how you add your own database into the NIST NIJ DIT, and then you can search it and do with it what you'd like. Thank you for taking the time to watch this video, and feel free to reach out if you have any questions or concerns. Thanks.